These next set of theorems here just talk about the antiderivatives of our common trig functions. And down here we have what happens if the inside of the trig function is a linear function, kx plus b, something like that. So we know our rules of differentiation for sine, cosine, tangent, so on and so forth. So it's pretty, it makes a lot of sense to think about going backwards for antidifferentiation. We know that the derivative of sine, over here, we know that the derivative of sine is cosine. We know that the derivative of negative cosine is sine. So down here, if on the inside of our sine or cosine integral, the argument is a linear function, so of the form a real number times x plus another real number, then all we do is divide by that constant and then follow the same rules as above. Effectively, what we're doing here is we're compensating for the chain rule. Because normally, if you were to differentiate this, right? If you were to differentiate cosine of kx plus b, you would have negative sine of kx plus b times k. We get the chain rule, which says we have to multiply by the derivative of the inside. Well, if we go backwards, instead of multiplying by the derivative of the inside, we would divide by the derivative of the inside. So that's what we have there. Okay, example 4. Well, the antiderivative of sine is negative cosine, but then we're going to divide by that leading coefficient on the inside, which is pi. So 1 over pi cosine of pi x plus c. For this one, we'll have 1 over 22 sine of 22x plus c. Now here we got to be careful, because if we look at the theorem, it says if k is not 0. Because if k is 0, we actually have the cosine of, well, 0 times x is 0, cosine of 0 is 1, so this is really just the antiderivative of 1 dx, which is just x plus c. Here, we'll have negative 1 over e cosine ex plus c.